Thank you. Fingers crossed, this all works. I'm a relative newcomer to OCaml. I work with a lot of people who know OCaml, but I've, despite many attempts, have failed learning it multiple times over the decades. But I really wanted to solve that. And at the same time, a couple of years ago, I came across this event called Tiny Code Xmas, and that's where there's a group of people who get together and do kind of fun graphic stuff and try and teach new people. And so this talk is about the kind of meeting of those two, my desire to learn OCaml and Tiny Code Xmas. And actually, I think Tiny Code Xmas suits OCaml quite well, and so I kind of want to tease that out a little bit during this talk. So there's a bit of context needed here before we get going, which is fantasy consoles. So there's a whole kind of genre of tooling called a kind of fantasy console or a fantasy retro console, and TIC-80 being one of the kind of more common ones. And things like TIC-80 and PICO-8, they kind of have the affordance of like an 8-bit or 16-bit microcomputer without the kind of hassle of trying to work out how to get code off GitHub onto a tape deck so you can load it onto your Commodore 64. Thank you, sorry. So these fancy consoles, they've got all the kind of restrictions from that kind of microcomputer age. You've got very limited pixels, limited palette depth, small amounts of memory. But they don't have, I say, the kind of hardware frictions of using those. And so around this, there's a whole community of people writing games, doing graphics effects, and having a lot of fun. And you may ask, kind of, well, why would you do this to yourself when we have modern computers that are good for things? And I guess it's a set of limitations that foster a certain amount of creativity, right? Being able to do a demo effect on a kind of 16-bit or 8-bit microcomputer forces you to think a different way, forces you to approach problems a different way, and that's fun. And it also is a nice leveling effect. So if you kind of take part in the community of people who do this, there's people of every level, and because there is only so far you can go visually on this, it's a very, egalitarian, I guess, somewhat domain. So it's a lot of fun, and I took part in one of the events that this community runs back in 2022, which is called Tiny Code Xmas. So the idea is that for the 12 days leading up to Christmas, they post a challenge a day with a short video and some text description, and they try and take new programmers from next to nothing to doing old school graphics effects that look quite cool and whizzy. And so I did that using TIC-80 in 2022, and so when I came to want to learn OCaml, it was kind of around Christmas time. I thought, this is great. I want to do this Tiny Code Xmas again, but I don't want to rehash what I did last year. And there's only so much lure I can take. And so I thought I'd approach it in OCaml. So this is day one of Tiny Code Xmas. You can see the staggering graphics capabilities I have here. Day zero of Tiny Code Xmas is download TIC-80, or in my case, get OPAM and put OCaml, and select a graphics library, which I'll show in a second. Then day one is just use the primitives, get something on screen, don't worry too much about it, just draw something basic. Day two is add snow. So here's the lure for the first day of Tiny Code Xmas. And the kind of thing I want to call out here is you've got the boot and tick functions here. Which is a kind of common idiom. I think we saw this on some slides yesterday even. So in TIC-80, boot is called once at start of day, and the tick function is called for every frame redraw. Other than that, it's quite imperative, as you might imagine. So clear screen 8. So 8 is a reference to the palette. The TIC-80 palette is conveniently on the right-hand side of the screen there, far away from me, so I can't point at it. But 8 is the middle, dark blue there. Your rectangle, something 12, which is white, and you can kind of see we're drawing the screen here. It's all very, very linear and very imperative. And so for 2023, it's doing this in in OCaml. So this is my first OCaml program. Don't judge me too harshly. I used the graphics module for OPAM because it's really simple, right? It doesn't offer many features, but as a new programmer, that's kind of what I want. I just want something that'll let me draw some squares and circles. And it runs on everything. Because it's X11 based, I can run it on Windows under WSL, I can run it on my Mac with Xports and what have you. This is where the first kind of benefit of OCaml kind of comes into play, in that you can write imperative code in OCaml, right? Although I'm trying to learn a functional language, as my first steps, I can literally just transpose the kind of Lua logic into OCaml and not get too distressed about tail recursion or whatever. The funny indentation here is because I come from more things like Swift and other languages. So when I saw let blah in, I thought, oh, there's a scope here for limiting a resource use. And so my indentation is trying to track all of the scoping for all of my variables. I appreciate that's not idiomatic, but that's kind of where my day one programmer brain went with the OCaml syntax. Day one, very simple. By day 5, you're doing things like this. And this looks kind of whizzy and kind of, wow, what's going on here? This is a kind of tunnel with panels and stuff. But it's actually a very simple set of trigonometric functions. And this is kind of where Tiny Code Xmas is quite fun, is because it's full of the kind of tricks and hacks that people did for these old school graphics to do whizzy effects on low budget, which means that they're great for teaching people because you can have small amounts of code that have high visual impact. And so it's very rewarding for people. So let's take this one apart. So let's stop time. Thank you. And this here is just the kind of superposition, I guess, of two functions. There's this one, which is a tan yx, effectively, and then bounded by the palette. And we have this one here, which is the width of the screen divided by the square root of x squared plus y squared plus 1. Again, like not the most challenging set of functions, but when you add them together, you get something that is more than the sum of its parts. And again, for each one, we can add a time component. So here, we're just adding time wrapped around the palette. And then here we've got time, but for fun, I've kind of run it through a sine function so that it kind of oscillates back and forwards rather than just continue with loops. And so with a few bits of math, which the Tiny Code Xmas folk explained to you, you can get something that has that kind of high satisfaction value for a new programmer. This is my OCaml code for that. You can see I've already gone to try and ape TIC-80 style. I've got my TIC function here. The other thing I think is super interesting about this effect here is that it's pixel functional, right? Every pixel is calculated independently of every other pixel. So I have this function that's in this for loop here that its inputs are x and y. And so I can calculate every pixel on its own. And also it takes in t as the kind of like progression of time. And so every pixel, you can calculate every frame independent of the previous frame. So it's got a slight kind of functional feel to it, right? I mean, it looks like a shader as well. That's another way of viewing this. But I refer to these as kind of like pixel functional effects. And other effects, as I went through Tiny Code Xmas, also seem to have more of a slight functional feel to them. What have we got? This is day 8. This one clearly isn't stateless. There is some state being the frame buffer being slid across and filled. But the position of those 5 spinning disks, they're all calculated in just based off the time reference t. And even something like this. This is a kind of functional effect. So for effects like this, you tend to generate your object. So here I'm just generating a 3-dimensional array of points. Then you apply a transform based on t to rotate them. And so every frame I can calculate just from the current frame t. Then you apply another transform that takes them from 3D space to 2D space. And this isn't proper 3D projection. This is just a bodge, right? But it looks 3D. And that's, again, the Tiny Code Xmas way of well, you know, Z is just, like the further away Z is, let's just move them closer to the center of the screen, and that's what perspective is, right? And so the maths is very simple. But you end up with this kind of functional pipeline of define object, rotate object, project object, render to screen. And I'll show you some kind of code of that later to show you what it looks like, but hopefully you can kind of see it has a functional feel to it. And then by day 12, you're still drawing Christmas trees, but hopefully you can see they've come a long way from day 1. So that's like the first run through Tiny Code Xmas. They actually do an extra challenge every day where they teach you more advanced effects. So if this all feels a bit below you, they have more kind of interesting things for you to do. And I continue to plug away and try and fill in my OCaml knowledge through these. So day 2 extra is doing divering effects. So you're kind of doing a random stippled diver to make sure it's stable. This is another point, transform, project effect. And then sometimes there's just random trigonometry that looks kind of cool. So this is the code for random trigonometry that looks kind of cool. The problem here is that I'm now carrying around so much code every day as I try and pretend I've got a TIC-80-like environment. I like that aesthetic of TIC-80, of the limited palette, limited screen depth. And so I'm trying to mimic this. And you can see that to get to the interesting code, I'm already on line 81 of my kind of supposed kind of do this quickly before dinner hacking project. And you know, my main loop is now more than 1 screen's worth of code. And this is getting a bit annoying. And I kind of like that Tiny Code Xmas kind of has this kind of easy to get used to and slightly functional feel, but I don't like this. And so I kind of hatch a plan to try and make it so that next year, or this year as it is now, if other people want to do this, maybe I can kind of package up all of this boilerplate and present it so that other people can kind of follow in my footsteps without having to implement their own kind of frame buffer simulator. At the same time, I saw this talk by Jonathan Hogg, the chap on the right here. He's a visual artist. He does light installations, physical art. I've seen him do gigs where he does all the projection lighting. And for that, he's a Haskell head, and he's written his own functional lighting system for running stage lights and things. And Flitter works by, you define a scene, you apply some physics kind of objects to it, which will do transformations over time. And so I really liked what Jonathan was doing with Flitter. And so between TIC-80 and Flitter, I made my own little kind of library for doing these kind of silly graphics routines called Claudius. And this was in time for January. So if you're still not worn out by Tiny Code Xmas, in January, there's an event called Genuary where you get a generative art prompt per day. And the idea is that you do whatever you like. There's no rules, just have fun. And so I had momentum, so I kind of kept going through all of this and used it to try and develop my own little graphics library in OCaml. And my objective was to try and make it such that it supported the kind of 3 idioms that I've kind of highlighted. One is the pixel functional effect. The one is the kind of building up your functional pipeline effect. And one is just imperative, because I think for new people, that's kind of newcomers to a language, having that fallback is still super useful. Ultimately, none of this makes sense. I'm not creating TIC-80. This doesn't have the same limitations and enforced limitations that TIC-80 gives you. It's all in your mind at this point. But it's still hopefully a lot of fun. So some practical examples. One of the art prompts was no palette. Claudius is palette-based. It has because I like that trapping of TIC-80. I like the limited resolution. I like the limited color set. But I also like playing in different fancy computer domains. Like maybe I want to do this one in the style of an old VGA system that's 320 by 200 by 256 colors. Or I want to make it look like an old Mac Plus with kind of 2-bit color. And so Claudius lets you have arbitrary colors, and so for no palette, I just do a lot of colors. But this is the code for this effect in Claudius. Hopefully, you can see I've got rid of a lot of the boilerplate. I can kind of quickly go to my pixel-oriented effect here. The kind of bootstrapping, you just specify what resolution you like, define a palette. You can have an optional boot function and a tick function. If you have a boot function, it's usually an indicator that it's not a very functional effect you're working on because you have to set up some initial state. But yeah, the kind of goal of letting you concentrate on doing the effect rather than the trimmings around hopefully has been met, and hopefully it's starting to encourage a functional style of thinking. This is another one. This is random dots. And so this has been great for me learning OCaml because I had to implement a whole bunch of graphics routines because I couldn't use any. At this point, I should point I'm using TSDL as my backing rather than graphics now. But I'm still working in a virtual frame buffer space, so I have to implement my own drawing routines because I'm an idiot. But you can see that the code is starting to have these kind of pipelines in them for, we generate sphere, we rotate it, we sort it by Z, which doesn't make sense because these are points, but if they were circles, maybe it would be more interesting. We render to the primitives types that Claudius can render, and then we just send it to the frame buffer. And indeed, mixing in some other kind of shader style effects up here where I'm fading out the previous frame, so it's a kind of more subtle movement. And over time, we have to add more primitives. This one was fun. This is kind of Islamic patterns, so we're kind of playing with the positive and negative space effect here of the rotating. But I felt it looked a bit weak just doing lines, and so implemented kind of filled polygons to kind of give it more impact. Claudius also I had to add kind of typography, and because I like old fonts, because I like old computers, I had to learn how to use Menhir, as I pronounce, the parser, so I could parse old BDF font files. And so at the end of this, you have this kind of array of primitives that we can render. So hopefully this would be enough to do everything that Tiny Code Xmas needs for coming this December. One of the kind of restrictions of what I've done is it's not TIC-80. There is no artificial boundary which I cannot go beyond, which goes against the kind of limitations for creative solutions. But on the other hand, I have OCaml. So one of the prompts was use a physics engine, and someone has written a hook spring simulator and put it in OCaml. And so I was able just to pull in random OCaml package here to satisfy the user physics engine. And that's it. That's I kind of run through the getting slightly carried away with a simple set of graphics challenges and learning OCaml. Is that one, I learned a whole bunch of OCaml. Maybe not quite to the effect where I've been understanding every talk here, but hopefully it's kind of bootstrapped me to on that trajectory. I do think the challenges that they do for Tiny Code Xmas have a good functional leaning, and I think that's interesting as a way of trying to get people to learn a language like OCaml where you've got that flexibility to work both functionally and imperatively. And the Lovebite community, I want to call out because who did organize it, was super welcoming to someone coming. Everyone else is doing it in TIC-80 and PICO-8, and I turn up and keep posting videos in from my OCaml code. But they still were very accepting of alternative ways of approaching it. So yeah, so my next goal is to try and get us into OCaml and try and write up some documentation for December this year when I'm told Tiny Code Xmas will run again, and then hopefully make it easier for other people to learn OCaml that way. So that's it, that's my talk. And in case it wasn't obvious, this is all written in Claudius. My slide deck is feeding my my code.
Thank you, Michael. That was amazing. Like the demo was just like crazy. Any questions? Sure.
Just curiosity, this reminds me when I started functional programming, I implemented this paper called functional geometry. I don't know if you heard about it.
No.
Basically, at the end, you end up drawing the square limit of Escher. Okay. So it's a very nice, maybe you can add it to your collection. Yeah. It's a quite old paper from the 80s.
Cool, thank you. I will check that out.
Just functional geometry, this is the title.
Thanks, Michael, for the talk. It was great. Kind of want to just ask more about your experience with OCaml, given that you didn't have maybe that much before, but have lots of experience in other programming languages, including their ecosystems. So you had to use OPAM, you had to use June and stuff like that. I was just wondering if you could talk a little bit about what you think works well and maybe what doesn't work so well and what could be improved from your experience doing this.
Yes, let me give me a sec. This is hopefully not going to be too embarrassing if I bring up the stickies, because I did write notes. Yeah, so let indentation aside, there were a bunch of things that tripped me up. Kind of exceptions versus ops kind of feels a bit. So I'm just going to say this, you can throw stuff at me later. The kind of division between when an exception is used and when an optional is used feels a bit random, or in fact, a lot of APIs support both, and so it's over to you, good luck. Whereas coming from a language like Swift, there's a fairly obvious delineation between exceptions and optionals. So that just felt a bit rough compared to the rigor I was used to. Kind of the cost of using arrays versus lists is, as a naive user, not obvious. And obviously, for me, when I'm implementing a frame buffer, lists feel like the thing you should be using because they feel functional. And then the kind of doing access to random elements obviously isn't well suited. And just things like I was trying to run before I could walk because I knew tail recursion was a thing. And then I didn't show it. There's a lot of, in my early code, list rev as I built up lists backwards and then flipped them right at the end because I wasn't quite sure how to do recursive functions to process lists properly. Again, which is not an idiom that you naturally do in other languages.
Good. Any more questions? No. Okay, then one more round.